Hi, in this video I'm going to show you how to use Visual Studio Code with CoCalc. There are two ways. One, in a CoCalc project, you can click a button and it will pop up Visual Studio Code running directly in your project on our shared Kubernetes infrastructure. You can then access all of your files exactly as usual and edit Python and other code, use their debugger, use their built-in Jupyter notebook, and so on. You can also very easily run Visual Studio Code on a compute server, which will provide vastly more power, potentially hundreds of CPUs, terabytes of memory, GPUs, or whatever else you need. So let me show you how this works. Here we are on the CoCalc landing page. I'm signed in, and I'm going to click to view my projects. And then I'm going to run the project called demos. Here it is. So first I'm going to run VS Code in this project. And for any project on CoCalc, running VS Code from that project is as simple as clicking the VS Code button right here. Or alternatively, you can click on servers and then scroll down and click VS Code. So let's just click this button at the top and launch VS Code. There we go. It's firing up and it will take a couple of seconds, and then VS Code pops up in another tab, and there you are. And you can then do various things. Let's make a new file. Demo.ipynb. Okay. We've now created our Jupyter notebook in VS Code. And now let's do a simple computation. So I'm computing 2 plus 3, but notice I haven't configured anything. And I need to enable using Python in a notebook interface. So let's install and enable the suggested extension. And now we're waiting for the extension to install. So see, it says installing Jupyter Notebook support. Okay, so it should now be installed. And let's select Python 3.10. Okay, so notice our Jupyter notebook is now running Python 3.10. Let's hit Shift Enter, and the notebook is starting up, and then we see our output 5. Now let's also draw a very simple plot. Import pylab.plot 1, 2, 3, 8. Now it's creating the plot and displaying it. Okay, and there we are. This is, of course, VS Code, so there are lots and lots of other things you can do. Like you can make a new Python file and work with it. And it shows you nice completions and all kinds of information and context and so on. So that's really nice. So look, we're seeing something about the source code of the print function. If we look back at our CoCalc original tab, notice each of the files we created is also visible in CoCalc, and you can also open them there if you need to. CoCalc itself gives you nice full real-time collaboration and other features. But editing code could be nicer in VS Code because of the excellent LSP support, where it shows you hints and completions and so on. Finally, one other thing you can do in VS Code that's really useful is make a new terminal. And that lets you do anything in Bash and type top or whatever. All right, so that's one way to use VS Code with CoCalc. And it just uses whatever built-in support you have in your project. So CoCalc projects, by default, they're running on a shared machine. It may have dozens of other users on it. The projects can be pretty slow if you're not paying at all. And even if you want to max out the resources that are provided when you pay, you still don't get very much, really. Like you can click upgrade your project, pay as you go for a couple of cents per hour. But even when you max everything out, as you can see, you only get, up to 15 gigs of disk space, 16 gigabytes of memory, and 3 CPUs, which really isn't very much. And that costs 22 cents per hour. And you could also buy a license, which is more powerful. In any case, let me show you the next thing that you can do, which is you can use a compute server to basically add compute capacity to this project and run VS Code on that, but you still have the same files available, and you also have additional space available if you want to download a bunch of data and work on it with on that other machine. So let's create a compute server. To do this, we'll just click Servers, Create Compute Server, and let's say I want a machine that has a lot of memory. And let's try say one of the new N4 instances. So I'll do N4 high mem, and then you can kind of see the restriction. And let's try something with 128 gigabytes of memory. And then I can choose which region I want to run it in. And it shows you, ordered by price, how much it will cost per hour to run the machine in that region. And also note up here, there are two different prices. Spot instances can be interrupted if there's a large amount of demand, whereas the standard instances won't be interrupted. But spot instances for CPU-based compute are often an extremely good value on Google Cloud because they have an absolutely ridiculously massive amount of machines around the world, and there are dozens and dozens of data centers. And a lot of the demand right now is for GPUs. And so if you're just looking for CPUs, you can often get away with using a spot instance for a day without it being interrupted, or even up to several days. It depends on the sort of machine you're using as well. But if you're doing something you absolutely cannot be interrupted, use a standard instance. Some other things about this configuration. This new N4 instance requires a hyperdisk, so that's what we'll have. And let's just make the disk a little bigger for fun. We'll make it 100 gigabytes. And other things, we're going to run VS Code. So it's really nice to set up DNS. Otherwise, you'll see, that way you'll get a proper SSL certificate. If you don't set up DNS, you get like these warnings in your browser, and it's kind of ugly. So let's just call this our VS Code demo. Okay, so we're going to have this domain name automatically allocated to us. Okay, other things, if you click automatic restart, if your instance does get interrupted, it's a spot instance, so there could be a lot of usage, then CoCalc will automatically restart it, so it starts running again. And finally, I'm going to click ephemeral. Well, no, I'll just leave that unclicked. But if you click ephemeral, what that does is it just changes the user interface to make it easier to completely delete the compute server when you're done with it. Okay, so we're done configuring the compute server. Now let's click Start. Oh, by the way, there's two other things. So the title, you can change this at any time, VS Code Demo. And you can also change the color. The color is used in lots of places to display the compute server. So you can just change it to whatever you want. It impacts like little accents related to the compute server. Okay, let's click Start. And there, our compute server is now starting up. And this will take, depending on the machine, could take 1 to 2 minutes. It's usually quite fast on Google Cloud, but a lot of things happen, takes a bit of time. Oh, by the way, one thing I didn't show you is that there's an image you can select, and I chose the Python image. There are a whole bunch of other images that you can select here. The default is Python, but there are many other options. Okay, look, it's now running. There's still a boot up process, and that's what this little blue slider shows. But once it starts running, you can click on this and then logs, and you can look at the serial console and watch the boot process, which can be pretty fun. So we're now seeing our computer booting up. And it runs various code. There's a little Docker image that provides a daemon that runs on the compute server. It connects back to CoCalc via a WebSocket connection and using an API key, and then there's communication back and forth over that WebSocket connection. That's how it's implemented under the hood. And by the way, you can also run a compute server on your own infrastructure. So if you don't want to use Google Cloud, you can click here when you're creating the compute server and select on-prem, and then paste a line of code in, and then it'll run the compute server on your own machine. Okay, everything's up and running. So now our goal is to run VS Code, and you can either click VS Code right here, and then that will install and launch VS Code, or we can go to this menu in the upper right and then click on VS Code, and the same thing happens. So let's just click, boom. Now, what's happening behind the scenes is it's installing the latest version of VS Code, which just takes a few seconds, and then it's starting up the server. And once the server is running, it will open this URL in another tab, and then we'll have VS Code running directly on the compute server. It's not running in the normal shared resources of the rest of CoCalc. It's running on the compute server, and we're directly connecting to that. So one implication is if the compute server is geographically close to you, it's going to feel even faster. So here we are, a brand new instance of VS Code is now running on the compute server. And we can open files, the same files we had before. So I'll close the other VS Code instance I was running. So this is running on the compute server, vscodemo.cocalc.cloud. And just to confirm that this looks like a reasonably powerful machine, let me open a terminal. And this is again going to run directly on the compute server. And now if I type, say, htop, I should see that there's a lot of memory. Look, this has 126 gigabytes of RAM. So this is completely different than anything you can get as part of the normal CoCalc project. Like a CoCalc project, you're limited to just 16 gigabytes of memory. It's very limited. Whereas with the compute server, I mean, you can get an absolutely enormous, many, many terabytes of memory, no problem. So here we are. Let's see. So it has 16 processors and lots of memory. And these processors are very fast as well. So anyways, let's try running Jupyter. This is a brand new install of VS Code. So if we try to run a cell, we should, in a moment, it should require that we install the extension because we're running it in an entirely new place. So let's see what happens. It says select kernel, Python environments. So let's select the kernel that's there. So it does know how to do that. I guess I didn't have to install any extensions. So that's nice. Must be just pre-installed into the environment. Okay, and I'm also able to draw this plot again. Let me make a little change. Boom. Let's try a little benchmark just for fun. From time, import time, t equals time, sum range 10 to the 8th. So it sums up the numbers up to 100 million and then displays the amount of time it took. And that took just under a second. Let me try that again just in case something's funny. Okay, so tried a few times. It looks like it's taking, depends on the time that I run it, but really what matters for a benchmark like this is what's the fastest time. And so we're getting down to almost 0.8 seconds. And if we try that on CoCalc in the normal default environment that I showed you over here, if you want a terminal here, just click new and then click Linux terminal. Okay, over here, let's do the same thing. And it's a little bit slower. Still pretty fast, but slightly slower. If you do top, you'll notice there's less CPUs and significantly less memory. That's in the CoCalc project itself. By the way, if you want to switch this terminal to run on the compute server, it's really easy. Just click the drop down. It shows your compute server, select it, and then wait a second. And now the terminal is running on the compute server, just like you saw with VS Code. It's very similar. And if you do this, you now see that we have 128 gigabytes of memory, and 16 processors. Okay, so now you've seen a whole bunch of different ways that you can run VS Code with a compute server and just in CoCalc itself. And just to clean up, notice that we have our server, it's running. This shows the total cost per hour of the compute server running in our project. If we click on upgrades and then go down a little bit, at the bottom you can see the cost accrued so far for this compute server that I started is 6 cents. So I started it up 6 minutes ago and it's cost a total of 6 cents. So it's about a penny per minute to run this powerful compute server. This N4 is a really cool new instance type. It's a 5th generation Intel Xeon processor. It's very, very powerful. Huge cache, etc. Okay, so now that you've seen using VS Code and using a compute server, I'm just going to shut down this compute server. And since I don't need the... Oh, let me show you one other thing on the compute server. So I forgot, it's kind of cool. Let's look at the terminal again. And remember I made a 100 gigabyte disk. So if you look, we have almost 100 gigabytes, so 91 gigabytes available. Let's say we are getting close to filling up that space and we need a little bit more space. All you have to do is go over to your compute server and click on settings and then scroll down to the disk and say, oh, I'd actually like, I don't know, 1,000 gigabytes instead of 100. Just make that change. It'll tell you how much it'll cost extra per month. Ooh, I noticed there's a typo right there. That is missing a space. I'll fix that. So it tells you how much it will cost. You click the button and you get the extra space. It's enlarged to that amount. And you don't have to reboot or anything like that. If you go back over and check in the terminal, within a few seconds, it's now going to have all of that space. So that's really nice. Feature of a compute server. You can easily enlarge your disk to be extremely large. And you can also use sudo and apt-get install anything you want. Your full root on the computer. I don't know, let's install X11 apps or something. And by the way, if you need to use an X11 app directly on a compute server, there is another application you can launch which is called X11 Desktop. And that, again, with one click lets you run X11 apps. So that's kind of nice. Okay, so we're done. I'm going to now turn off the compute server. And because I'm not going to use it anymore, instead of just stopping it, I'm going to deprovision it. Once I do that, there's no cost at all. It deletes my data. It's just gone. So it deletes the data that's only on the compute server. So here we go. Done. All right, thank you. And I hope you have fun testing out CoCalc and using it for fun and also serious computations.